This is an early stage 1 experiment. Here we're looking at what does a plant need to grow. Our syllabus content is reviewing the characteristics and basic needs of living things, and our inquiry question is what do we notice about living things? It's important that we recognize that living things have basic needs, including air, food, and water. In explaining this to students, it's best to use a video.
The needs of a plant.
For a plant to stay alive, it needs 5 things I would not lie. It needs water so it can grow. And it needs soil just like so. Plants need space, they can't be tight. The sun helps plants by giving light. Don't forget to give plants air. Repeat the needs if you dare. Need 1, water. Need 2, soil. Need 3, space. Need 4, light. Need 5, air.
A plant.
In order to investigate this, we need to implement our working scientific skills. We'll question and predict by stating a research question, hypothesis, and aim. We'll plan and conduct by making observations when we record our data. We'll record observations through photographs and communicate that. Our research question is what does a plant need to grow? Our aim is to investigate what plants need to grow by putting cress seeds in soil versus damp paper. Our prediction is soil will grow better because it's most similar to the natural nutritious environment. Here, we review the syllabus point of participating in a guided investigation to identify living things and the external features of plants and animals in our local environment. Our variables in this experiment include the dependent variable as the growth. Our independent variables are soil, and our second one is paper towel, and we have extraneous variables to consider like the degree of sunlight, the weather, the rain. We will need to design and produce an effective way to record our data. This has been chosen in a table where we have observations for 6 days and use photographs to display such. The materials include 3 containers, 3 cotton paper towels, 1 small container of soil, and 60 cress seeds, 20 per container. The procedure is as follows. For the soil method, place 3 to 4 centimeters of soil in the bottom of the container. Water the soil lightly and sprinkle seeds evenly over the surface. Use a spray mist bottle to water the seeds every day for 6 days. When watering, photograph. The wet paper towel procedure includes placing a few layers of moist paper towel at the bottom of a small container 3 times. Sprinkle the seeds over the surface of the paper towels. Use a spray mist bottle to water the seeds every day for 6 days when photographing. On day 1, the seeds were planted. By day 2, they began to bud. On day 3, the seeds sprouted significantly. And day 4, this continued. It's observable that the sprouting continued more in those in the soil than those on the paper towel. Unfortunately, day 5's photograph was lost. However, there was a lot of growth in the sprouts in the soil due to an increase of sunlight, as it was a particularly sunny day. Day 6 continued to grow and sprout significantly in those in the soil. As seen from the continuing watering, nutrients from the soil, and exposure to sunlight, the cress seeds grew much more rapidly than those in the paper towel. Comparing the 2 independent variables, first being the paper towel and second being the soil, we can now answer our research question, stating, in addition to water and sunlight, soil is needed for plants to grow. In considering elements of design and production, it's important to identify and describe needs or opportunities for designing, like considering confounding variables like weather, sunlight, and rain. It's also important to identify technologies needed to achieve our design solutions. For example, considering the importance of having a camera to photograph in order to correctly communicate results, as communicating is a very important working scientifically skill. Extending the experiment, we can do this within a classroom and compare results with peers. This is a form of replication and will allow you to be sure that it wasn't by chance, but rather the scientific purpose underlying the results that gave us our said results. This will also allow you to ensure that it was a fair experiment.